9.1. Number 4, just a vocab, factorial. Number 4 was factorial. Number 12, you were just plugging and chugging. Didn't they say find the first 5 terms? So if they ever give you an nth term formula, or if a multiple choice question has lots of different nth term formulas and you need to make it match to a sequence, you can say, whatever, plug in 1, who should he be at the first? Plug in 2, who should be second? Plug in 3, plug in 4, plug in 5. Now they showed all the work, but for the answer, couldn't you guys have just done 3, comma, 12 elevenths, comma, 9 13ths, comma, 24 47ths, comma, 15 37ths? But you should have done the work of plugging in 2. Just plug in 1 through 5. Number 22, same dealio, plug in 1 through 5. But what did you notice with this little negative 1 dude? What happened when you kept on adding another one, adding another one, adding another one to the signs? Yeah, it alternated. Positive, negative, positive, negative, positive, and it's going to keep on doing that. And this sequence, which you could have written once again with commas, 1/2, comma, negative 1/5, comma, 1/10. Started with a positive because when you plug in 1, they put n plus 1. 1 plus 1 is 2, is squared. They started with a squared negative 1, or they started with an even power. What if they wanted it to start with a negative and then go positive? What could you change in the formula? If it was supposed to be negative 1/2, then positive 1/5, then negative 1/10, what could you change? Yeah. Take away the 1. You could take away the 1 and then just have it be negative 1 to the end. So if you plug in 1, sweet, it's a negative. If you plug in 2, now it's a positive. Plug in 3. You could take away the 1, or you could add another 1 and make it n plus 2. Either way, it would bump your positives and negatives to not be on the second and the fourth, but to be on the first and the third. Okay. Number 60, you were finding the first 5 terms again, but wait. Do you notice what they said to do? Start when, n is 0. So you actually only went to 4 because you had 4 terms here. The 5th term was that 0. But you had to remember 0 factorial good is defined to be 1. And then plug in the rest. Once again, could have separated with commas. Could have separated with commas, totally fine. Number 64, it was one of those fun simplifying ones. Could you have actually figured out what 12 factorial was, and 4 factorial, and 8 factorial, and multiplied, and divided? I guess. Or you could have seen 1 through 8 is in both. And so 8 factorial reduces away with his 8 factorial. He just has also 9, 10, 11, 12 left. But then you also had this 1 through 4 that would have been left as well. So I don't know, like 2 and 4 is 8. Oh, he already got canceled out. 3 and 4 is 12. Yeah, that's a good one. 3 and 4 could take away the 12 entirely. 2 could reduce with the 10. So you have 9 times 5 times 11. When you reduce, 9 times 5, 45. 45 times 11 is 495. Or you could have, you could have done the 3 with the 9 and the 2 with the 10 and the 4 with the 12. There are many different ways, but either way you're reducing. If you did it that way, 3 and 9, that'd be a 3, and then a 5, and then a 3, which would have been 15, 45, and 11. Oh yeah, same thing, 495. So there are a lot of different ways of like breaking it down, but either way, 495. Now, hold on, pause. Is it good to be able to do this in your calculator? Yeah. Ah, calculator's open. Did anybody find the factorial, the exclamation point in their calculator last night? There is an exclamation point. It's underneath the math menu, but not the first math menu. Not the second math menu. Probability. Probability. This has to do with probability? Section 9.6, 9.7. Yeah, it does. Is it good to be able to use your calculator? Yeah. Well, you have to do some things by hand. Yeah. Just be careful. I didn't take roll yet. Sorry, I got distracted. And then number 74. Once again, could you have done that in your calculator? No, they use a J. Can you use whatever variable you want in your calculator? Yeah. So you could have put little i's, you could have put little k's, you could have actually done little x's because the x variable button is really easy to push. But actually what they were asking you to do, even though they didn't say it explicitly, I would say it a little different on a test. I would say solve for the sum by expanding. Expanding is what they did. Expanding is, oh, let's plug in 1 and 2. We stop at 4 because it says to stop at 4. We start at 0 because it said to start at 0. And then you guys could do this a few different ways. But the easiest way is probably just to do it piece by piece, term by term. So you get 1 minus 2 is a negative 1, plus 4 is a 3, minus 8 is negative 5, plus 16 is 11. But is it good to be able to use your calculator for that as well? Yes. So really quickly, powwow in your groups if there's any questions you have as far as using your calculator for the factorials to be able to get that answer or for the summation to be able to get that answer. You need to be able to do it by hand, but also by calculator. Yeah, math. Did we not do it yesterday? Sorry, math and then go up. Math, the first menu of math, go up because it pops you to the bottom of the list. And then you see summation. Yeah. Now you have to choose a letter to put in there. Remember how I said any letter is okay as long as the same letter you use under is the same letter you use in the formula? So I would use the X button because it's instead of J, instead of I, instead of K, I would just use X. But you can use I's and J's using the alpha button if you really want to. Yeah, double check in your groups. Make sure everyone's okay on the calculator for finding the factorial and for doing the summation. You guys coming up with any questions? Let me see. Oh, it just has to do with the programming, how they did it. I don't know why. I think it's because, see, they put that guy. Oh. Hey, guys. Careful. A lot of you guys are getting 1. Are a lot of you guys getting 1 for 74? You got 11? Uh-oh. Getting something else. You have to be careful when you put it in your calculator. You could be using alpha J. That's totally cool. You could also be using just the X button, because that's also totally cool. I think that's easier to push. If you go X is 0 to 4, here's the problem. When they show you parentheses, these parentheses start and end what they put in here. So if you do -2 to the J or to the K or to the I or to the X, I should do X because I put X here. If you do it here, you're saying, do this for this guy and then raise it to that. But you don't want this to happen later. You need it to happen now. So you can't put it outside because this ends this whole program. I need to put it inside. So try putting your variable inside the parentheses. The parentheses are saying start the sum, end the sum. So put it inside, which means you have to put the -2 in parentheses because you have to raise the negative to powers also, not just the 2, but the negative also. And then it should, A, look a little more normal and not have a weird like power way up in the middle of nowhere. And it should give you 11. Is that working better? Okay. How many of you guys are using the X, just so I know? How many of you guys are using like J, like whatever letter they give you? You guys using? N's fine. Oh, why is it saying N? What mode are you in? You're in sequence mode, but what if you were in function mode? It would be giving you, and it's okay. It's fine. You can use that button. That's totally fine. But yeah, N works also. I forgot that you guys would get that in sequence mode. Are we okay in our calculators, though? Okay. Because like the matrix test we just took, it was really beneficial to know how to use your calculator, right? Okay, you just couldn't use it all the time. I think that's it as far as even. So what questions do we have, Joe?
For this chapter, are we going to be in sequence mode like the whole time, or are we going to have to switch back?
I don't really think there's a purpose to switching back. I'm thinking real quick. Yeah, you can be in sequence mode the whole time. Yeah, it's okay. And not that we really use sequence mode even all that much, but some of you might have used it in homework a couple times. Yeah. Okay, I took roll, and everybody's here. Just Tyler, you were tardy excused. Okay, not Tyler, Lauren. Sorry. I wrote down the right one and said the wrong one. You were earlier this week, Tyler, because of the painting on the street or something like that. Okay, cool kids. So we're good on 9-1? That was fairly painless. Cool. Let's go ahead and go to 9-2. And get rid of all that. Let me freeze the screen for just a second. Those of a pineapple, Fibonacci numbers show up there. But as you guys are getting back into notes and back into section 9.2, we're going to narrow our focus on this type of sequence. Joe, go ahead. What's your question?
Isn't like
lots of patterns in Pascal. Also in Joe, if you might already know Sierpinski's triangle, there are a lot of different patterns in that as well. And we're going to see Sierpinski's triangle in a video that we'll watch in section 9.3. Yeah. But yeah, there are lots of patterns in Pascal's and Sierpinski's. Okay, arithmetic sequences. Special sequences where difference between, oh, that's totally a math term. What's the difference? Subtraction, good. So where the difference or where the subtraction, which you guys should have already written down below, right? Between any two consecutive. What's consecutive mean? Not same.
adjacent?
Yeah, like adjacent or one right after the other, right? If a president serves 2 consecutive terms, what does that mean? He got reelected. Does that make sense? He was a president for 4 years. He got reelected in another 4 years. 2 consecutive terms. That's one place that we hear it kind of often. So 2 consecutive terms, okay, not like serving for president, but coming back here, 2 consecutive terms, one right after the other. So if we subtract the second minus the first, the third minus the second, the fourth minus the third, all of those subtractions end in the same guy. But an easier way of seeing the pattern, at least in my head, is because that difference between them is constant. Guess what's also constant between them? How to get from the previous to the latter. You're always going to be adding the exact same number, which is that same D. So to work backwards, once it's already given to you, you can check and see if it's arithmetic. If by subtraction, they all end up with the same number, or you can just look in your head and say plus, 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 is it all the same? The common difference, that's the name for that little letter D. But let me give you a quick example. Do I have some good ones on the next page already? Kind of, sort of. What if I was to give you this guy? What if I was to give you something like 20, 15, 10, 5, 0? Is he arithmetic, yes or no? Yes, because 15 minus 20 is negative 5. 10 minus 15 is negative 5. 5 minus 10 is negative 5. 0 minus, okay, get the point. But what's another way of looking at it besides the subtraction? How do you get from 20 to 15? Okay, some of you would say subtract 5, which would go against the pattern unless you remembered subtraction is just addition of the opposite. Oh, so I'm adding negative 5. Does that make sense? So just because we're adding doesn't mean we're always getting more positive. Sometimes we're going down instead of going up, and that's okay. But the question remains, are you adding the same constant every time? And the answer is yes. So therefore, what would be your common difference for this guy? Negative 5. Not positive. Positive is going more positive. Negative going more negative. So here's the question. What if I wanted a sub 7? What if I was to ask you for this guy? Just kind of exploring with him just for a little bit. What if I was to ask you for the 7th term? How many do we have so far? 6. So if I wanted to find the 7th term, what would you guys answer? But what if I was to ask you for the 50th term? All right, let's get out our calculator. Minus 5, minus 5, minus 5, minus 5. Hold on. Well, recursive formula says minus 5, minus 5, minus 5. Which, I mean, we could keep doing, but wouldn't that be tedious after a while? It'd be tedious before we even start. Okay. Is there a pattern if we're repeatedly doing the same subtraction over and over and over and over and over? Guys, how many minus 5s ended up needing to happen between here and here? 2, right? So to get from the first term to the third term, we had to do 2 negative 5s. Huh. How about to get from the first term to the 6th term? Not 6. 1, 2, 3, 4, 5. Have you guys noticed if you're going from like a first to a fifth that there are always, even just look at your hand, 4 spaces in between? 4 jumps, right? Okay. So if, see the pattern? You wanted to get straight to the 50th from the first, and all of your jumps are exactly the same, couldn't you just make one jump of how many negative 5s? 49. Oh, that sounds a whole lot easier than doing minus 5 49 times in my calculator, right? Repeated addition is the same thing as multiplication. So if we can just figure out how many repeats happened, how many repeated jumps happened, well, man, that'd be a whole lot easier. We'll have a formula for that in just a second. For right now, let's go ahead and go back to the basics. Let's go back to the basics. Right now, it's just asking, are these arithmetic sequences? Because not all sequences are. Arithmetic is a very special category where it has to have a common difference. So, they didn't even give us a sequence in letter A. Yeah, they did. They just gave us the formula for the sequence. This is an A sub n, right, guys? Not an A sub k where you had to know the last guy. No. This just says plug in. So how do we get our sequence? Plug in 1. When you plug in 1, what do you get? Can I just like write it like this? Is that okay? Okay, plug in 2, what do you get? 8 and 3 is 11. Plug in 3, what do you get? 12 and 3 is 15. Plug in 4, what do you get? 16 and 3 is 18. Well, 19. There you go. 16 and 3. Looks pretty arithmetic to me. How come? Yeah. If we can find a common difference, or 11 minus 7, 15 minus 11, 19 minus 15, if we can find a common difference, it's arithmetic. So yes, right? But do you also see how this formula shows me it's arithmetic? Because if you plug in 1, isn't it 4 times 1 plus 3? If you plug in 2, wouldn't it be 4 times 2 or 4 plus 4 plus 3? 2 4s? If you plug in 3, wouldn't it be 4 plus 4 plus 4? 3 4s? What's happening every time? You're adding in 4, right? So every time a multiplication gets higher, you're adding in another. If repeated addition is multiplication, then multiplication is repeated addition. Anyway, but you could write it out and see the pattern pretty quickly. How about letter B? A sub n equals n squared. They actually gave us the sequence. Aren't they nice? 1, 4, 9, 16. Yes or no with arithmetic? No. There is a pattern. 1 squared, 2 squared, 3 squared, 4 squared. But arithmetic says there needs to be a constant or a common difference. Isn't that 3 and that 5 and that 7? And it's a pattern, but is it constant? Nope. So there is no common difference. There's a pattern, but not a common difference. So therefore, nope, no siree. There's a pattern, but it's not arithmetic. Okay. Here's an arithmetic. I want you guys to take what we just did, going from the first to the 50th, going down by negative, or I should say, adding negative 5s every time. I want you to try to apply it to this new sequence that's also arithmetic, where I want the 20th term. I give you the first 4. I want the 20th. there is a formula. Some of you guys got to see it for a second. I'm going to now cover it up. We'll get back to it in a moment. Let's see if you logically understood how we got to the 50th term a second ago, and you can apply it to this one. Okay, powwow in your groups. Do you guys agree? Either on what you're thinking or what you're doing, or maybe even what answer you got. Talk it out. All right, if your logic matches up, if you haven't gotten to the 20th yet, go ahead and try. If you have gotten to the 20th, make sure you guys agree. And I want you to think about the formula. Let me unveil it again so you can write it down. This is known as the nth term formula. Let me go ahead and put little quotes in so you guys can see. The nth term formula. Oh, that's why I didn't put quotes in there. Here. Ha. Let's see if the formula makes sense, if your logic matches. Maybe you guys could have come up with this formula. What did you guys do? What pattern did you see, first of all?
Plus negative 5, minus 5.
Oh, man. I should have chosen something else for my last one. I didn't realize they would be the same. Okay, so plus negative 5. So then what? Starting at 2. Maybe you guys could have come up with this formula, because what does the formula say? For any arithmetic sequence, you can start at the first term, and then you can add whatever n is, take away 1. To get to the 5th, only 4 jumps. To get to the 20th, 19. To get to the 50th, it was 49. And then just multiply. So did you guys all end up with negative 93? Nice. Now, how can we technically use our calculators? I'm not going to take a lot of time with this, but our calculators, how could we have used them in sequence mode to check that we were right? Well, we could have added negative 5 19 times. Okay, well, that's kind of boring. Don't we know how to use sequence mode? Couldn't we have said, ready, u of n is equal to u of n minus 1 minus 5? Could we have done that? Remember, a sub k is equal to a sub k minus 1, take away 5. Isn't the pattern every time? Look at that guy minus 5. Look at that guy minus 5. Right? And we could have had our n min being 1. And then we could have had our first term, whether it's u of n min, whether it's u1. We could have had it be 2, because it's our first. Wouldn't you guys have then gone second graph? Wouldn't you have gone to your table? And didn't we look yesterday where you can have it on ask instead of auto, and couldn't you have just plugged in 20? Check it real quick and make sure you can still use your calculator. Does it pop out? Ooh, negative 93. Because you could have done u of n is u of n minus 1 minus 5. Just reminding you of the recursive programming idea where we could tell our calculator to do the pattern for us. But if we can't have our calculator, or if a question is saying use the nth term, well, it's going to be a lot easier since we're not the calculator and we can't do all this math over and over again in our heads really fast and keep track of it in a nice organized way. Well, it'd be a lot easier to follow this pattern instead. If you guys are a highlighting kind of person, these next couple sections are going to have quite a few important formulas. This is the beginning. Highlight this guy. He's important. The nth term formula for arithmetic. You guys getting negative 93 also? Go to your table, type in 20. You should have your window as ask. Okay, just reminding you how to use that recursive stuff. What's this one say? Find a formula. Oh, this one we have to find a formula. Like it's not even just finding a term, we have to find a formula. Okay, find a formula for the nth term of the arithmetic sequence whose common difference is 3 and whose first term is 2. Well, hold on. Did you guys understand the formula on the last page? Maybe it would help you memorize it better. Do you remember what a sub n is always going to equal? Start at the first, good. Add however many jumps of your common difference you need. Okay, plug and chug, what you know. They give you, they give you the common difference is 3, so just plug in d is 3. They give you the first term is 2. Well, this isn't hard. If a sequence is arithmetic, coming up with the nth term formula isn't hard because they're all going to follow the same pattern. What was hard in section 9.1 is they just threw all these different sequences at you, and you're like, I don't know. I don't think I gave you too many in homework, though, did I? Of the sequences where you had to come up with your own formula? Okay. Because remember, I said it was hard. It's a multiple choice question on a test. You'll have a lot of nth terms. You just have to find the right one by like plugging in. But if it's arithmetic, you can go from just a couple clues to the nth term formula real fast. Now, they're not going to stop there. Come on, we can simplify. We can do math, right? So plus 3n minus 3. Like, we'll keep going. It's not going to necessarily look just like that at the end. But this gives us where to start. 2 minus 3 is negative 1, so 3n. So that's kind of nice. We don't have to like just come up with an a sub n term right off the top of our head. We don't have to make up a formula. We can follow a pattern because it's arithmetic. But we have to keep an eye open for what kind of sequence it is. Either we find the pattern if they give it to us like this, or we watch out for the wording if they give it to us like that. Is that cool? Okay, so what else do we have? Oh, just got a little more interesting. Why don't you plug into that a sub n formula again as much as you know, and then ponder, if I can get my a sub n formula, how can I use it to figure out when 129 will occur? And some of you are like, well, I'll get my calculator and I'll just start plugging in numbers and go find 129. Well, that is one way. Using sequence mode is a lot more strategic than like just following the pattern until you get there and then counting up how many additions you did. That's kind of annoying. If you did the whole recursive thing and you could do u of n is u of n minus 1 plus, what's the pattern? Oh, plus 7. And then if you had the table do it automatically, not asking, well, I guess eventually you get to 129. But let's say you can't use the calculator. What have you guys gotten so far when you plugged into a sub n is equal to a sub 1 plus n minus 1 times d? What do you know? First term and d. But why is Tyler saying we know a sub n? Do you see it? So, I mean, yeah, we could say a sub n is equal to, and we're totally right. We could simplify all that jazz, but we could also say, wait. We know where we're supposed to be ending. We just want to know when it happens. So technically, yeah, you could have plugged in 129 also. If you plugged in 129, took away the initial 3, said, okay, well, how many jumps of 7 was that? You guys see how the math is answering these questions? And then 7 into 12 is 1, and 56, that's 18. And then say, oh, but remember, 18 is 1 lower than the actual term. It's the 19th term. Took 18 jumps, and since it took jumps, it must be the 19th term. Does that kind of make sense? Putting all the things together, all the clues? So that's kind of cool. Not only can we find the common difference, not only can we jump ahead, but we can also say, oh, hey, I think this is a term in the sequence. When will it occur? When will it happen? When will it show up? Oof, but what if I give you something like this? I give you the 4th, I give you the 7th, I ask for the 1st. But I tell you it's arithmetic. What makes it harder? I really wish you gave me the 4th and 5th, or the 6th and the 7th. But don't you know how many jumps are in between the 4th and the 7th? Pause, think, ponder, what does that mean? And what if I was to go backwards the path? Don't say it out loud, don't go like blurting it. Some of you would be right, some of you would be wrong. Just think about it. You know how many jumps are in between the 4th and the 7th. If you don't like this, you could be doing, if that helps, you could be doing this. 5th, 6th. We're looking for him. And we know that you're adding by the same number every time. Don't blurt it out. Think about it. Hold on, I have to do it in my head. Who else thinks they have it? Don't say it out loud, just raise a hand. What do you think it is? No, not 6. Keep thinking. Yes, but then you have to work backwards with that. Yes. I've got a couple right answers. No. You don't want to be looking here. You need to be looking here. You need to be looking at the relationship between 7 and -5 and the placement, but not like directly subtracting. I don't think, unless I didn't hear you right. Has anybody figured out that the big difference is 12? Have you guys figured out? Like the big difference was going down 12? But wasn't that big difference done in 3 equal jumps? So what would those 3 equal jumps be?
4.
Down 4, down 4, down 4. So then, well, this must have been down 4 and down 4 and down 4. So if it went down 4 to get 7, what would it have been before? Can't you go backwards? Wouldn't that be 11? And then wouldn't that be 15? And then wouldn't this be... And if you don't trust me, well, 7 down 4 is 3. 3 down 4 is -1. -1 down. Oh, it works. But do you see kind of logic made it happen? Now, some of you are like, oh, I can do that logic. I got it. Some of you beat others. Because your common mathematical sense is stronger than others as far as like just the common, practical, everyday, sweet. But others of you are like, I just wanted to use my formula. We could have. We've just been a little bit nasty because we didn't know him. And we didn't know him. We had 2 unknowns. So we could have plugged in. We knew the 4th term was 7. But the problem is we couldn't have solved for D or A1. We could have plugged in that we know the 7th term is -5. Oh, and it's a system of equations. We could have done some work. You could have done it mathematically with a little baby system formula. But some of you are like, no, I get that. That was -12. Cut up in 3 was -4. So then add 4, add 4, add. Got it done. Both ways would have worked. Solving the system, you would have found not only D to be -4, but also A1 to be 19. So there's one more formula. There's one more formula. Not just jumping ahead to get an nth term, but also jumping ahead to get an nth sum. Remember in section 9.1, we not only had sequences, but we also had series. Sequences had to do with just terms with commas separated. Series had to do with adding them all together. Adding them all together, that's a sum. Adding them all together, well, that's what the formula is before you. But if you guys notice, depending on what they give you, I'm going to put an or just to help you, to find what we would call an nth partial sum, to add up however many terms they want in this special arithmetic sequence. We could take n over 2 times a1 plus, if they were really mean and they didn't give us a sub n, we could throw in the formula for a sub n and say, fine, I can do it myself. Now, if they give us a sub n, it's not bad, it's kind of nice. But if they don't give us a sub n, well, it's going to be a little bit nasty. But here's how the formula works. If we want to add all these together, unless we realize our common difference is 2, our a sub 1 is 1, and if we counted 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, our a sub 10 is 19, we could say we want our 10th partial sum, plugging in our formula. 10 over 2 times 2 plus 19. Oh, I didn't see my first term. As you guys are packing up, let me just show you where this formula comes from. 20 times 5 is 100. If you add 1 plus 19, it's 20. 3 plus 17 is 20. 5 plus 15 is 20. 7 plus 13 is 20. 9 plus 11 is 20. Oh my goodness, it's just repeated 20s. Kiddos, I want you to still try for homework on Monday. We might not grade it until Tuesday, but we are moving on to a new section, like after a few minutes of covering maybe like 1 or 2 more examples. But you have your important formulas. Try homework as far as you can. Sound good? See you guys later. Happy weekend. Almost. We probably won't grade till Tuesday, but still throw into Google Classroom your attempt and come with questions. We'll try to answer.